Hello students, welcome to Time Classes. So we are going to start Geometry and Mensuration 4 and the handout code is same QAHO 1002040. So this is bring back handout. I hope you are all set for today's class. Alright, shall I start? Perfect. In the last class we have discussed centroid, median, incenter, circumcenter, orthocenter, Euler triangle, and all the properties of triangles. So far, the various type of centers are concerned. Right? Today I am going to start similarity of triangles. Let's say we have two triangles, ABC and DEF are basically two triangles. And these two triangles are basically A, B, C and P, Q and R are two triangles in such a manner that angle A is equal to angle P, right? Angle B is equal to angle Q, angle C is equal to angle R. So basically all three angles are equal. So if all three angles are equal, then the pair of triangle is known as similar triangle. So the ratio of corresponding side would be equal. If the triangles are similar, so we use this kind of notation. If triangle ABC is similar to triangle PQR, then AB upon PQ is equal to AC upon PR is equal to BC upon QR. Let's say this is M is to N. So can I say the ratio of corresponding side is M is to N? So what is the meaning of corresponding side? Side opposite to equal angle is called corresponding side. Let's say this angle is equal to this angle. So your corresponding side is AC and PR. So the ratio of AC and PR, ratio of AB and PQ, ratio of BC and QR is M is to N. The ratio of corresponding side would be in the same ratio, right? Simply, if one of the triangle is magnified without changing the angle, right? Now, if you simply magnify, then you get the similar triangle. Zoom in and zoom out, you will get the similar triangle time and again. The ratio of everything would remain the same. This point is very important. This is, you can say, note number 1. Note number 2 is ratio of perimeter is equal to ratio of corresponding side. Ratio of corresponding side. Ratio of perimeter is equal to ratio of corresponding side. Ratio of perimeter is equal to ratio of corresponding side. If the ratio of corresponding side is M is to N, the ratio of perimeter is also M is to N. Now, note 3. Can I say the ratio of corresponding side is equal to ratio of corresponding median, because In every triangle we have three median AD, BE and CF. Similarly, we have PX, QI and RZ. So ratio of corresponding side is equal to ratio of corresponding median is equal to ratio of corresponding altitude, ratio of corresponding altitude is equal to ratio of corresponding angle bisector, is equal to ratio of in radius. If the ratio of corresponding side is m is to n, the ratio of in radius is also m is to n is equal to ratio of circumradius, etc. Everything remain in the same ratio except the area. This is note number 4, you can say. You can see over here, if the ratio of corresponding side is m is to n, so if this is mk, then this would be nk, and height will be also in the ratio m is to n. So let's say this is your height. So height is also in the ratio m is to n. Let's say this is m into x, then this is n into x. If the base is in the ratio m is to n and height is also in the ratio m is to n, then ratio of area would be simply the duplicate ratio of the corresponding side. If the corresponding side in the ratio m is to n, then the ratio of area would be m square is to n square. Alright, I hope this is fine. Okay, let us practice few questions based upon similarity of triangle. Now look at the question. Given that angle ABH is 90 degree, AB is parallel to CD, which in turn parallel to EF and GH. So all these lines are basically 90, 90, 90, parallel, parallel, parallel and parallel. All these lines are parallel. If the length of AB and GH is 10 and 15 centimeter respectively, AB and GH is 10 and 15. So if this is 10, then this is 15. Right. We want to calculate the length of CD and EF. So first of all, ignore EF. Try to figure out the length. Try to find out the length of CD. Let's say CD is X, BD is Y, and DH is Z. You know that AB is parallel to CD is parallel to GH is parallel to EF. AB, CD and GH. If these lines are parallel, can I say triangle HCD will be similar to triangle HAB? This triangle and this triangle is similar. So HD upon HB means Z upon Z plus Y. Can I say Z upon Z plus Y means HD upon HB is equal to, can I say CD upon AB? CD upon AB is equal to X upon 10. So Z upon Z plus Y is equal to X upon 10 is my equation number 1. Similarly, If you consider triangle BCD and BGH, can I say triangle BCD is similar to triangle BGH. So y upon y plus z, y upon this is equal to this upon this is equal to x upon 15, right? If you add equation number 1 and 2, 1 plus 2 will give you z by z plus y and y by y plus z is 1 is equal to x by 10 plus x by 15, x by 10 plus x by 15, can I say? So if you keep x in the left hand side, it would be 1 by x is equal to 1 by 10 plus 1 by 15. You can treat this one as your direct formula. Of course, we can calculate the value of x. So can I say from here 1 by CD is equal to 1 by AB plus 1 by GH. Whenever we have this kind of diagram, right, 1 by CD is equal to 1 by AB plus 1 by GH. So what is x? 1 by x is 25 upon 150, right, is 1 upon 6. So x is equal to 6 is the length of CD. But what is the length of EF? If I extend the same funda over here, can I say 1 by CD plus 1 by GH is equal to 1 by EF? You know CD. 1 by CD, 1 by GH is equal to 1 by EF, and x is equal to 6. So 1 by EF is basically 1 by 6 plus 1 by 15 is 21 upon 90. So EF is equal to 90 upon 21 is equal to 30 upon 7. So length of ECD is 6 and length of EF is how much? Length of EF is 30 by 7. So the first part, EF is how much? EF is 30 by 7 and CD is how much? 6 centimeter. And we have a formula. Whenever we have a parallel line like this, the 1 by AB plus 1 by GH is equal to 1 by CD. This is called cross ladder theorem. Whenever we have a figure like this, whenever we have cross ladder kind of thing like this, this line is parallel to this line is parallel to this line, and let's say this is x, this is y, and this is z. We always have formula that 1 by x is equal to 1 by y plus 1 by z. I hope this is fine. Okay. Now look at the question number 47. What is given? ABC with point P on AB and AP is 1/3 of AB. So this is my triangle ABC. P is present on AB and Q is a point on AC. And AP is 1/3 of AB. Can I say if PQ is parallel to BC, then this angle is equal to this angle is equal to this angle, and this is common. So AP upon AB is equal to AQ upon AC. AP upon AB is 1 upon 3. It is given in your question. So point Q on AC is such that AQ is 2 centimeter longer than AP and PQ is parallel to BC and AC is 4 centimeter more than twice of AQ. So if this is X, right now, according to your question, AP is 1/3 of AB and find Q and AC is such that AQ is 2 centimeter longer than AP. If this is X, if this is X plus 2, and if this is X, can I say this total would be 2X because AP is 1/3 of AB. If this is X, then this is 2X. And AQ is 2 centimeter longer than AB. If this is X, then this is X plus 2. And AC is 4 centimeter more than twice of AQ. So AC, this complete AC is 2 times X plus 2, 4 centimeter more than twice of AQ plus 4. You need 2X plus 8. Now just use this similarity property. Triangle APQ is similar to triangle ABC. So AP upon AB is AQ upon AC. AP is how much? X. AB is how much? 3X. AQ is X plus 2. And AC is how much? 2X plus 8. Can I say this is 1 upon 3 because X upon 3X is 1 upon 3. So 2X plus 8 is equal to 3X plus 6. So X is turning out to be 2. And we want to calculate the length of AP, and AP is X, so AP is equal to 2 centimeter. Can I say? I hope this is fine. The simple application of similarity of triangle APQ and triangle ABC are similar. Next one is again a question based upon similarity of triangle. Consider the triangle ABC where BC is 12. BC is 12. DB is 9. This is 9. This DB is 9. BC is 12. CD is 6. This CD is 6. And angle BAC is equal to angle BCD. BAC, can I say this angle is equal to BCD is equal to this angle. Now in this question, it is not very difficult to see that triangle BCD is similar to triangle BAC. Why? Angle B is common and this angle is equal to this angle. So BCD is similar to BAC. What is the ratio of corresponding side? So side opposite to equal angle is called corresponding side. So side opposite to this angle is 9 and side opposite to this angle is 12. The ratio of corresponding side is 9:12. Can I say if the ratio of corresponding side is 9:12 means 3:4, the ratio of perimeter would be also 3:4. Can I say? We want to calculate the perimeter of triangle ADC. So first of all, what is the perimeter of triangle BCD? So far BCD is concerned, it is this plus this plus this is 27. If 3 is 27, then 4 is 36. Can I say this is the ratio of perimeter? The ratio of corresponding side is equal to ratio of perimeter. So 9 plus 6 plus 12 is 27. So ratio of perimeter of bigger triangle is 36. Right? Side opposite to equal angle is called corresponding side. You can see over here. Can I say if this is 6 and this is x, then 6 and x are side opposite to equal angle B, opposite side is 6 in this triangle, angle B opposite side is x in bigger triangle. So in a smaller triangle, opposite side of angle B is 6. In bigger triangle, opposite side of angle B is x. Can I say 6 upon x is again 3 upon 4. So 3x is 24. So x is turning out to be 8. If this is 8. So 12, 8, 20. And 20 and 16 is 36. Since the perimeter of triangle BAC is 36, so 12 plus 9 is 21, 21 plus 8 is 29, so length of this portion is 7 centimeter, can I see? Then the perimeter would be 36 centimeter, and we want to calculate the perimeter of triangle ADC. Can I say the perimeter of triangle ADC would be simply 7 plus 6 plus 8 is equal to 21 centimeter. I hope this is fine. Alright. This question appears to be slightly bulky. In the figure, P is a point inside the triangle. So this is your point inside the triangle. And DE, FG and HI are drawn through P. So one of the line is DE. Second line is FG. And DE is parallel to AB. FG is parallel to BC. And IH or HI is parallel to AC. Right? Can I say if these are parallel lines, AB is parallel to DE, FG is parallel to BC, and DE is parallel to AB is parallel to DE, FG is parallel to BC, and IH is parallel to AC. Now tell me one thing. Can I say triangle IFP? Right now, triangle, you can start from DPG in the same order in which your question is given. Triangle DPG, triangle FPI. Rather, you can write in the same order because these triangles are similar. IFP is triangle PEH. PEH. And triangle ABC. Now tell me all these triangles are similar or not. Why? Because you can see over here, can I say this angle is equal to this angle because lines are parallel? Can I say? And since this line is parallel to this line, so this angle would be equal to this angle. Corresponding angle, corresponding angle, corresponding angle. In the same fashion, can I say this angle is equal to this angle is equal to this angle? In the similar fashion, can I say this angle is equal to this angle is equal to this angle is equal to this angle? So angle I, D and P are corresponding angle. In the similar fashion, it equals to angle A. So this angle, this angle, this angle, this angle equal. Similarly, F, P, E, B is equal. Similarly, I, G, H and C equal. So can I say all these triangles are similar? This is similar to this, similar and similar. So but the ratio of area is concerned, can I say the ratio of area is 1 is to 9 is to 25. If the ratio of area is 1 is to 9 is to 25, can I say the ratio of corresponding side would be 1 is to 3 is to 5? Because as per your theorem, if the ratio of corresponding side is m is to n, then the ratio of area is m square is to n square. So other way around, if the ratio of area is m square is to n square, then the ratio of corresponding side would be m is to n. Now look at this side. Can I say if this is x, this is x, can I say? If this is x, since this line is parallel to this line, AB is parallel to D, can I say if this is x, this is x? Let's assume that this is y and this is z. Okay. Now tell me one thing, what is the ratio between x, y and z? X, y and z are the ratio of, if this is x, this is y and this is z. Can I say this x, y and z are the ratio of corresponding side? And according to your question, x, y and z are in the ratio 1 is to 3 is to 5. If this is k, then this is 3k, then this is 5k. So if x is k, y is 3k, then z is 5k. Can I say this side is again the corresponding side? Can I say? So in triangle ABC, can I say the ratio of corresponding side is 9? If this is k, this is 3k, then this is 5k, then the BC is 9k. So x, y, z and x plus y plus z is the corresponding side or not? X from this triangle, y from this triangle and z from this triangle, and from bigger triangle we have x plus y plus z. Since x, y, z is in the ratio 1 is to 3 is to 5, so in the same term x plus y plus z, the corresponding side of bigger triangle can be written as 1 plus 3 plus 5 is 9. So what should be area of triangle ABC? Can I say 81? If the ratio of corresponding side is 1 is to 3 is to 5 is to 9, the ratio of area would be 1 is to 9 is to 25 is to 81. Can I see? Yes, let us move to the next one. The next point I am going to discuss is circles. There are lots of concepts in triangle, property of triangle, ratio of area equal to ratio of base. So triangle is full of concepts. Now circles is, you can say, relatively easy right now because we have fewer properties in circles. The first and foremost property of circles is, you can say this is note 1. Two circles are congruent. Two circles are congruent when their radius is equal. Two circles are congruent when their radius is equal. These two circles are congruent. Why? Because their radius is equal. And two circles are identical in all respect if their radius is equal. So circle, you know the locus of point which is equidistant from the center of the circle. Alright. So let us start with few nomenclatures of circle. If two circles intersect each other, then how many points are common? 2 points are common. These 2 points are, let's say, A and B. So the point is, note number 2, between two intersecting circle, exactly 2 points are common. And one step further, if I move one step further, if 3 points are common, between two circles, then the circles are identical. Means if 3 points are common, then there is no point of being a different circle. Then the circles would be identical. Identical means they will coincide with each other. So the point is, if we have 3 non-collinear points, we can draw a unique circle. So the point is, this can be also written as an unique circle can be drawn from a set of 3 non-collinear points. Non-collinear points. So between two intersecting circle, exactly 2 points will be common. If 3 points are common, then those two circles are actually the equal circle or identical circle. Or suppose we have 3 non-collinear points like this. So we can draw a unique circle through this point. Right now, we can draw a unique circle through this point. Right? So from any 3 point we can draw a unique circle. This concept can be used in the problem solving of permutation and combination as well. So note 1 is clear. Note 2, between two intersecting circle, exactly 2 points are common. And if 3 points are common between two circles, then the circles are identical. An unique circle can be drawn from a set of 3 non-collinear points. Alright. Let's say we have a circle. Such kind of line is called, can I say, MN is secant. The line which passes through the point is called secant, and AB is chord of the circle. So we must be ready with this nomenclature. MN is secant and AB is chord. Alright. Now, MN is secant, AB is chord, then ACB is known as minor arc and ADB is known as major arc. ACB, this curved length is called minor arc, and this ADB, right, is called major arc. Suppose O is the center of the circle, and if you draw the perpendicular on any chord, AB and AD are two chords, if you draw the perpendicular right now from center, then it would be by default a perpendicular bisector. So this relation is vice versa true. Note 5. Perpendicular bisector of any chord always passes through the perpendicular bisector of any chord always passes through the center of the circle. Perpendicular bisector of any chord always passes through the center of the circle. Or other way around, if you draw the perpendicular from the center on the chord, it would be by default a perpendicular bisector. So this length is equal to this length and this length is equal to this length. Right? Now, one step further, this is node 6. Let's say this is your center and these are the perpendicular bisector. So let's say this length is equal to this length. If this is x and this is x, if the distance from the center is equal, if the distance from center is equal, then chords are of equal length. Again, this relation is again if and only if correct. Perpendicular bisector always passes through the center. If the distance from the center is equal, if this is x and this is x, then this implies that AB is equal to AD. So if the chords are of equal length, then the distance from the center is equal, or other way around, if the distance from the center is equal, then the chord of the length is equal. So equal chord is equidistant from the center. You can also write equal chords are equidistant from the center. Equal chords are equidistant from the center. I hope this is fine. Now, suppose length are not equal. In this case, length is equal, but suppose x and x is not equal. This is your note number 7. Let's say this is x and this is y. Let's say this is AB and this is AD. Of course, this is center. So if x is greater than y, if x is greater than y, then AB is lesser than AD. Or if x is less than y, then AB is greater than AD. Means longer chord is always nearer to the center. longer chord is always nearer to the center. So if AB is longer than AD, then X would be smaller than Y. So longer chord is always nearer to the center and the shorter chord is farther from the center. I hope this is clear. If this distance is greater than this distance, then AB is shorter. If this distance is less than this distance, then AB is longer. I hope this point is clear. Alright. This is note 8. AB and AD are two chords of equal length. Then their angle bisector always passes through the center. If AB and AD angle bisector between two equal chord, always passes through the center, always passes through the center. Angle bisector between two equal chord always passes through the center. So if this is the angle bisector, it always passes through the center. If this is theta, this is also theta, then the angle bisector passes through the center. But the point is, these two chords should be of equal length. These two chords must be of equal length. So angle bisector between two equal chord always passes through the center. So you must know which line can pass through the center, which line cannot pass through the center. What happens in most of the time, we normally draw something line, or we normally assume that it will pass through the center. You can't assume that your line will pass through the center. If you draw any line and you claim that it will pass through the center, you must have some strong logic, right? It must be validated by some important axiom, theorem, or notes, right? The next one is note 9. Center to point of contact. This is called, PQ is called tangent. So PQ is tangent. So center to point of contact is always perpendicular. Center to point of contact is always perpendicular, right? So center, line joining the center, the line joining the center and point of contact right now is always perpendicular. So if this is L, this is M, then L is perpendicular on M. I hope this point is clear. Now let us discuss some more point related to angle. This is note 10. Angle made by diameter. At the circumference of circle is always 90 degree. Angle made by diameter at the circumference of circle is always 90 degree. So this angle is 90 degree provided that this line is passes through the center or diameter. Right? We all know this property. Next one, note 11. Let's say this is your triangle ABC and this is DBC. So angle made by the chord in the major arc is always acute angle. If this is theta, theta is always acute angle. Angle made by the chord in the major arc is always an acute angle, right? And note 12 is angle made by the chord in the minor arc is always an obtuse angle. So angle made by the chord in the major arc is acute angle. So this is your chord BC and this is your major arc. So angle BAC is theta, acute angle, but angle BDC would be obtuse angle. So theta and alpha. So theta is acute and alpha is obtuse angle. And one more thing, this is note number 13. These two angles are always supplementary. So theta plus alpha, right? Theta plus alpha is always 180 degree. So theta and alpha is supplementary angle. Theta plus alpha is equal to 180 degree. I hope this point is clear. So if this is theta, then this angle alpha must be 180 minus theta. These two angles are always supplementary angle. Or in a cyclic quadrilateral, if ABDC is a cyclic quadrilateral, so sum of the opposite angle is always 180 degree. If this is theta, then this is 180 minus theta. And if this is beta, then this angle is 180 minus beta. So angle made by the chord in the major arc is acute, minor arc is obtuse, and these two angles are always supplementary angle. Right? And you know this property. This is note 14. Angle made by the chord at the center is twice that of the circumference, is twice that of the, yes, this is very popular property. Angle made by the chord at the center is twice that of the circumference. So if this is theta, then this is 2 theta, or if this is 2 theta, then this is theta. All right. Note 15. Angle made by the chord in the same arc of the circles are of equal magnitude. So angle made by the chord the same arc of the circle, in the same arc of the circle are of equal magnitude. So these are the angles made by the chord in the same arc of the circle, and all these angles are of equal magnitude. So if this angle, if your chord is BC, then angle BAC is theta, BAC is theta, BC is your chord, then angle BDC would be also theta, then angle BEC would be also theta. And the converse of this theorem is also true. It is like, this is note 16. Let's say we have a chord. Let's say BC is a chord, and let's say angle BAC is equal to angle BDC. BAC is equal to BDC. If this angle is theta and this angle is also theta, then this 4 point AB DC, right? ABDC is conocyclic point. Means these 4 points lies on a circle. These 4 points must be conocyclic. If angle BAC is equal to angle BDC, then A, B, C and D lie on the circle. A, B, C, D are conocyclic point. I hope this is fine. Okay. Now the next note is known as note 17, is basically alternate segment theorem. Alternate segment theorem. Let's say PQ is a tangent. PQ is a tangent. And this is your chord AB. Right now, rather you can take this way. Suppose your chord is AB. This is point C. So angle made by the chord AB, angle made by the chord AB at the tangent PQ, at the tangent PQ is, let's say, theta. This angle is theta. So angle made by the same chord in alternate segment is also theta. So what is the alternate segment of this chord AB? This is your one of this segment and this is your alternate segment. So angle made by the chord, you can write angle made by the chord with the tangent is equal to angle made by the same chord in the alternate segment, right? Alternate segment. So angle made by the chord with the tangent is theta is equal to angle made by the same chord in alternate segment at point C would be also theta. So these two angles are of equal magnitude. Angle made by the chord with the tangent is theta, then angle made by the same chord in alternate segment here is also theta. This is your figure number 1. Now figure number 2. Angle made by the chord with the tangent. So this is your chord, AB is your chord, PQ is your tangent, and let's say this angle is 180 minus theta. So angle made by the same chord in the alternate segment is 180 minus theta. So angle made by the chord with the tangent in this part is 180 minus theta, then in alternate segment it would be also 180 minus theta. So angle made by the same chord in the alternate segment would be also 180 minus theta. Right? This is called alternate segment theorem. So you can see over here, if this is theta, then this is 180 minus theta. So angle made by the same chord in the two segments are supplementary angle. Angle made by the chord AB at C is theta, then at D is 180 minus theta. If you club these two, then opposite angle would be supplementary. I hope this is fine. You can see over here, if I go with the logic, let's say this is your center. Center to point of contact is always perpendicular, can I say? So if this is theta, the rest of the part is 90 minus theta. And if this angle is 90 minus theta, then this angle would be also 90 minus theta. Why? Because this is radius, this is also radius. Isosceles triangle. So 90 minus theta, 90 minus theta is 180 minus 2 theta. So this angle would be how much? 2 theta. If this is 2 theta, then it would be theta. You got the logic? Center to point of contact is 90 degree. If this angle is theta, the rest of the part is 90 minus theta. And if this is 90 minus theta, it would be also 90 minus theta. So 180 minus 2 theta plus 2 theta is 180 degree. So if angle BOA is 2 theta, then angle made by the chord BA at the circumference would be half of the angle made by the chord BA at the center. If this is 2 theta, then this would be theta. Or you can say angle made by the chord in the alternate segment are of equal magnitude. Alright. So note 1 to note 17. Right. I'm going to use all these properties right now. All these properties in the upcoming question. So let's start with one simple question. Question number 50. So what your question says, AC is diameter and ED is parallel to AC. AC is diameter and ED is parallel to AC. And angle CBE is 65 degree. And you want to calculate the measure of angle DEC. This can previous year question. AC is parallel to ED, right? Or ED is parallel to AC. Can I say, if you are interested in this angle DEC, let's say DEC is theta. You are interested in this angle theta. Can I say if this is theta, then this would be again theta, alternate angle, because AC is parallel to ED. If this is theta, then this is also theta. Now tell me one thing, angle made by the chord, you can see over here, we have a chord AE. Can I say angle ACE must be equal to angle ABE? Yes or no? This must be theta. If you draw over here, if angle AC is theta, then angle ABE is again theta. ACE is theta, then ABE is again theta. Angle made by the chord AE at point C and B would be of same magnitude. And you know that angle made by the chord, right now, angle made by the diameter at the circumference is 90 degree. CBE, this angle is 65 degree given in your question. So angle ABC is 65 degree plus theta and it must be equal to 90 degree. So theta is necessarily 25 degree and we are interested in this theta only. So this theta is 25 degree. I hope this is fine. So we shall quickly start the next part. Thank you. Hello students, welcome to Time Classes. So let us continue with the circles. In the last part we have discussed some important points related to circles, especially some notes related to angles of a circle, angle made by the chord, alternate segment theorem, right? Or minor arc, major arc, supplementary angle, etc. And we had just solved one question based upon the property, that was question number 50. So let us start with question number 51. In this question, we need to find out the measure of angle CPB and ABF. CPB and ABF. We want this angle, right? This angle, and ABF is this angle. They are the unknown. The first thing that is, you can say, evident from this figure, we know that opposite angles are supplementary in a cyclic quadrilateral. ABCE is a cyclic quadrilateral. See, this angle is 78. So this angle must be 102. 102. Right? 78 plus 102 is 180. Alright? One more thing. Can I say that these two angles are equal? These two angles. Because we know that common tangents are of equal magnitude. So these two angles are equal. This angle and this angle, because this and this side is equal. Alright. Now, this angle is 36 degree. This angle is 102 degree. So this angle is, sum of the three angle of a triangle is 180. So 138 plus 42 degree is 180. And you know that angles in alternate segments are equal. So if this angle is 42 degree, this angle must be 42 degree. Angles in alternate segments are equal. Angle made by this chord at the tangent is 42 degree, is angle made by the same chord in alternate segment, which is 42 degree. So if this angle is 42, can I say this angle is also 42 degree? 42 and 42. Can I say? Because these two sides are equal, isosceles triangle. So 42 is 84. So this angle is 96 degree. Can I say? Sum of the angle is 180 degree. So 42 is 84 and 84 and 96 is 180 degree. Now this angle is 42. This angle is 102. So 144. So measure of this angle is 36 degree. Can I say? 36 degree. I hope this is fine. Alright. So answer is 96 degree CPB and ABF is 36 degree. Alright. Next one. Now in the adjoining figure, angle BAD is 65 degree. Angle BAD is 65 degree. So this total angle, this angle is 65 degree, right? Can I say if this angle is 110 degree, opposite angles are supplementary. So can I say this angle is 70 degree? Yes or no? 110 plus 70 is 180. Angle E and angle D are supplementary angle. Can I say angle AEB plus angle ADB is 180 degree. So ADB is 70 degree because this angle is 110 degree. Alright. Now this angle is 100 degree. So opposite angle is again 100 degree. Can I say? If this is 100, this angle is again 100 degree. So can I say this angle must be 30 degree? This is from exterior angle property in this triangle. If this angle is 100 degree, vertically opposite angles are equal. This angle is 70 degree. This angle must be 30 degree. 70 plus 30 is 100. If this angle is 70 degree, can I say this angle must be 35 degree? Angle made by the chord, rather written just opposite, is 140 degree. Can I say? Not 35, 140 degree. Angle made by the chord at the center is twice that of the circumference. If this angle is 70 degree, can I say angle AOB, this is point O, angle AOB is twice of angle ADB, is 2 times 70 degree is equal to 140 degree. Can I say these two are radius? AO and OB is radius. So 140 degree plus something is 180 degree. So if this angle is 140, measure of these two angle is 20 degree and 20 degree. Can I see? This side is equal to this side, isosceles triangle. This angle is 140 degree. So 140 plus 20 plus 20 is 180. Now you are interested in this part. This part. We have to find out the magnitude of this angle. Can I say angle CAO? Angle CAO is nothing but 65 degree minus 30 degree plus 20 degree is 65 minus 50 is 15 degree. I hope this is fine. 65 minus 50 is equal to 15 degree. Okay. Alright. So let us move to the next question. All these questions, all these properties we already have discussed in the last segment. Now, two non-equal circles touch each other at point M. So these two circles are of some radius is not equal, which is given non-equal circles. AC is direct common tangent of these two circles. So point A and point C are the point of contact. AB and CD are chords. AB and CD are chords. If angle ABM is 30 degree, so let us start from here. ABM. Can I say this angle is 30 degree? We can use alternate segment theorem in this question. You know that angles in alternate segments are equal. So this is your tangent and this is your chord. So angle between tangent and chord is equal to angles in alternate segment. So angle made by this chord in this segment is 30. So this angle must be 30 degree. So this angle and this angle equal. So angle made by this chord with the tangent must be 30 because angle made by the same chord in alternate segment is 30. Now, we know one more property, that common tangents are of equal length, right? If you draw the common tangent, can I say this angle is again 30 degree? Why? Because this tangent and this tangent are equal. So if this is 30, then this angle is also 30. Let's say This point is E. So EA is equal to EM because common tangents are equal. So angle EAM is equal to angle EMA is equal to 30 degree. So 60 degree. So can I say this angle is also 60 degree from exterior angle property 30, 30, 60. Now again, can I say EM is equal to EC. So angle CEM, this length is equal to this length as well. So angle CME is equal to angle ECM is equal to 60 degree. 60, 60, 60. And you know that angles in alternate segments are equal. So if these two angles are of magnitude 60 degree, so this angle is also 60 degree, can I say? 60, 60, 60. Why? Because common tangents are equal. So if this is 60, these two angles are also 60. And angle made by this chord with tangent is 60. So angle made by the same chord in alternate segment is also 60. So from alternate segment theorem, we can say that angle CDM is equal to 60 degree. I hope this is fine. From alternate segment theorem, measure of angle CDM is again 60 degree. Alright. Now, in the following figure, PAB is an equilateral triangle. The measure of angle DCB is 20 degree and the length of DB is 7 centimeter. Find DC. Right. First of all, triangle PAB is an equilateral triangle. If triangle PAB is equilateral, so this is 60 degree, this is also 60 degree, and this is also 60 degree, 60, 60, 60. And look at the triangle ABC. In triangle ABC, can I say if this angle is theta, this angle is also theta? Why? Because angle made by the chord, let's say this point is E, chord DE at point A and B must be equal. So angle DAE is equal to angle DBE, and this must be theta. Look at the triangle ABC. Can I say this angle is already 20 given in your question? So 60 degree plus theta plus 60 degree plus theta plus 20 degree is equal to 180 degree. So 2 theta is 40 degree. So theta must be 20 degree. So theta is equal to 20 degree. Right? If theta is 20 degree, can I say triangle DBC is an isosceles triangle? If triangle ABC is an isosceles triangle, then DB is equal to DC. This side is equal to this side. Why? Because angles are equal. So according to your question, DB is 7 centimeter. So the DC is again 7 centimeter. I hope this is fine. Alright, okay. Now come to the next one. In a circle, two parallel chords on the same side of diameter having length 4 and 6 centimeter. If the distance between this chord is 1 centimeter, then find the radius of the circle. Now according to your question, distance between the chord is 1. So this is 1, and let's say this is X. This is O. One of the chord is AB, and the second chord is CD. Let's say this is perpendicular, so it would be perpendicular bisector. That's why the distance between the two chord is 1 centimeter. This is R and this is also R. We need to calculate this R. And you know that center to perpendicular on the chord is by default a perpendicular bisector. So this is 3 and 3, 6, 2 and 2, 4. Now look at the triangle. We have two right angle triangle. Just focus upon this right angle triangle and this right angle triangle. We can use Pythagoras theorem. Can I say R square is x square plus 3 square is equation number 1. Now the second equation is R square is x plus 1 square plus 2 square. This is equation number 2. X square plus 3 square is x plus 1 square plus 2 square. So x plus 1 whole square minus x square is 3 square minus 2 square is 5. X plus 1 plus x and x plus 1 minus x is equal to 5. So 2x plus 1 is 5. So x must be equal to 2. Right? X is 2. So if x is 2, can I say R square is 2 square plus 3 square is 13. So R must be equal to square root of 13. Can I say square root of 13? So radius is square root of 13 centimeter. So this is your answer. So in similar kind of question, we normally create a situation like this. Radius is equal. Sometimes we forgot to use, you can say, such kind of relations with the help of radius, and always try to find out some opportunity to use Pythagoras theorem whenever it seems possible. Okay, the next point is I'm going to use two property. Let's say P is a point, AB is one of the chord, and CD is another chord. Right? P is a point, AB is one of the chord, and PT is the tangent. So we have one property that PA into PB is equal to PC into PD. We can straightway use this property. I am not interested in the proof of this. If you are interested in proof, you can consult your reference material, and the proof of this property is linked with similarity of triangle. So PA into PB is equal to PC into PD, and here PA into PB is equal to PT square. And this rule is applicable for this figure also. Suppose we have two chords which intersect each other, like suppose this is your circle, right? and if two chord intersect each other like this, one of the chord is AB and second chord is CD, A, B, C, D, and P is the point of intersection, then PA into PB is equal to PC into PD. Right? PA into PB is equal to PC into PD. This is figure number 2. So this is applicable for figure number 1 as well as figure number 2. Right? Next one. In the figure given below, right, you can consider this as your important note as well. This is note. This again note. We shall use these property very frequently in problem solving, right? So please come to the next question. Question number 56. ABC is a triangle. D and E are the midpoint of BC and AC. So basically AD and BE are medians. Alright. Are medians. This is point D. This is point C. E, P, B and A. Find the ratio of length of PD and AC. So we are interested in the ratio of PD and AC. Then how should we proceed in this question? Since AD and BE are median and point P is the point of intersection of median, right? So P is equivalent to centroid, and you know that P will divide the length of the median in the ratio 2:1. So can I say AP is to PD is 2:1? Can I say if this is 2x, then this must be x, and if this is y, this is also y. So AP into AD is equal to AE into AC. Can I say AP into AD, AP into AD? We already have discussed this property. PA into PB is equal to PC into PD. Similar to this, we have AP into AD is equal to A into AC. What is AP? AP is 2x and AD is 3x. AE is y and AC is 2y. So 6x square is equal to 2y square. So x square is to y square is equal to 2 is to 6 is equal to 1 is to 3. So x and y is turning out to be 1 is to root 3, and x and y is nothing but PD is to EC. So PD is to EC is basically 1 is to root 3. Alright. Again, this is the application of your previous funda. Now come to question number 58. Now look at the question. Two circles with center A and B intersect it at points P and Q, so that angle PAQ and angle PBQ are 60 degree and 90 degree respectively. What is the ratio of area of circle with center A to the area of circle with center B? So first of all, write the information that you already have. So 60 degree and this angle is 90 degree. Basically, this is right angle triangle. If I join these 2 points, if I join these 2 points, can I say this side is equal to this side radius of the circle? So this is 60, this is 60, right? 60 and 60. Alright. So if this is R, this is also R. Can I say this is again R? And these two angles, can I say, are 45 degree and 45 degree. Why? Because again these two are radius. So basically this is 45 45 90 triangle, and if your triangle is 45 45 90, you know that if 45 45 90 triangle is given, then the side opposite to angle 90 degrees R, then the side opposite to angle 45 degree would be R upon root 2 and R upon root 2. Because in 45 45 90 triangle, then the ratio of side is 1:1 root 2. So if R is root 2, 1 and 1 is R by root 2 each. So what is the ratio of area? So area of triangle, area of the circle rather, with center A is pi R square, and area of the circle with center B is pi R by root 2 square. So pi R square is to pi R square upon 2. The ratio is turning out to be 2:1. So what is your answer? Your answer is 2:1. I hope this is fine. Alright. Okay. Now, come to question number 59. Question number 59. So what your question says? Your question says that DFCA is a rectangle. So DF is length and DA is breadth. So DA, EB and FC are equal. EB is perpendicular. So DA is parallel to EB, which in turn parallel to FC. AB is 9, this is 9, and this is 4. Find the value of A plus B, area of this portion, right? A, area of this portion, plus area of this portion, minus area of this portion. We need to find out. Right? This question is appearing to be very tricky. A plus B minus C, we need to figure it out. Now, first of all, can we calculate the breadth of the rectangle? If AC is known, AC is 9 plus 4, 13. So 13 is the diameter of this circle. Right? Let's say area of this portion is X. This whole portion. Apart from this C, the rest of the portion of the semicircle is, let's say, X. Right? So can I say A plus B minus C A plus B minus C can be written as X plus A plus B minus X plus C. Can I say? X and X will be cancelled out. And what is X plus A plus B? X plus A plus B is basically the area of rectangle. Area of rectangle. And what is X plus C? X plus C is basically area of semicircle. So area of rectangle and area of semicircle. Okay, so A plus B minus C is area of rectangle minus area of semicircle. For area of rectangle, we already know the length of the rectangle. So we know the breadth. Breadth is DA or EB or FC because all these three lines are parallel. Had it been complete circle, it will look like this. Right now, it will look like this. If you extend this part, can I say, since this is diameter, can I say if this part is FB, let's say this part is A, then rather this part is, let's say, P, then this part is also P, right? So 9 into 4, can I write BA into BC is BE into, let's say, this, we have BG, can I say BE into BG. So BA into BC is basically 9 into 4. So if this is P, the rest of the part is also P, is P into P. So P square is 36. So P is turning out to be 6. So the breadth of the rectangle is 6. So 9 plus 4 is 13 length and breadth is 6. So area of the rectangle is 13 into 6 is equal to 78. And so for the area of semicircle is concerned, it is simply pi 13 by 2 whole square. Can I say pi 13 by 2 whole square half, can I say, because this is semicircle. So my answer is A plus B minus C is turning out to be 78 minus pi by 8. 13 by 2 square is 8, 169. So 78 minus 169 pi by 8 is my answer. But in this question, what is most important element to judge what is my requirement? My requirement is simply area of rectangle minus area of semicircle, because A plus B minus C is x plus A plus B minus x plus C. X plus A plus B is area of rectangle and x plus C is area of semicircle. Alright. In the following figure, the measure of angle BAD is 90 degree. So this angle is 90 degree given in your question. And the length of line segment joining the point E and F is 15 centimeter. So line segment joining the point EF is how much? E to F is 15 centimeter as per your question. And BC and CD are diameter. BC and CD are diameter. So of course the center of these two semicircle would be here. Let's say one of the center is P and the other center is Q. We want to calculate the length of AC. Okay. How should we proceed in this question? AC, EF is given. We want to calculate EC. Rather AC. EF is given. Find the length of AC. Can I say angle made by diameter at the circumference is 90 degree? Can I say is 90 degree? So this length is basically 90 degree. This angle is 90 degree. Similarly, angle made by diameter CD at point F is again 90 degree. Can I say this angle is again 90 degree? So 90, this is again 90, 90, this is again 90. So 90, 90, 90. So the rest of the angle is also 90. Remaining angle is also 90. And can I say AFCE is a rectangle whose diagonals are of equal length? So if AFEC is 90, 90, 90, 90 rectangle, so diagonals must be equal. Can I say AC must be equal to FE? Yes or no? AC and FE are diagonals. Diagonals are of equal length. So AC is equal to 15 centimeter. This is very tricky question. The point is angle made by diameter at the circumference is 90 degree. Angle made by diameter is 90 degree, and this angle is 90 degree previously given in your question. So 90, 90, 90, 90 means diagonals must be equal. Whether it is rectangle or square, it will hardly matters. Alright. Okay. Now, the next point is direct common tangent and transverse tangent. Direct common tangent and transverse tangents. Let's say this point is P, this point is A, this point is B, this is C, this is D. Just draw the angle bisector. Naturally, it passes through the center of the circle from the symmetry property. Again, can I say if centers are M and N, then MA is perpendicular on PB, NB is again perpendicular. So triangle PAM and triangle PBN are 90, 90 means right angle triangles. This is 90 degree, this is again 90 degree. In the similar fashion, let's say this point is P, this point is A, this point is B, this point is C, this point is D. And if I draw the angle bisector, such kind of tangents are known as transverse tangent, and this is called direct common tangent. So figure 1 represent the direct common tangent, whereas figure 2 represent the transverse tangent. Center will lies on this line, this is M and this is N. So center to point of contact is 90 degree. Can I say this angle is 90 degree? And center to point of contact is again 90 degree. Right. For this, just sake of simplicity, I'm just changing the name. Let's say this point is M, this point is M, and this point is N. Just notice the triangle PAM and PBN in both the figure. Can I say triangle PAM is similar to triangle PBN in both the figure? 90 degree, 90 degree, PAM, PBN. Similarly, PAM, this is 90 degree, and PBN, this is 90 degree. In figure 1 and 2, PAM is similar to PBN. In figure 1, AB is direct common tangent. In figure 2, AB is transverse tangent. So can I say PA upon PB is equal to PM upon PN is equal to MA upon NB is equal to R1 upon R2 is equal to R1 upon R2. R1 is the radius of this circle, R2 is the radius of this circle. R1 is radius of this circle, R2 is radius of this circle. So first of all, this relation is very important. In many problem, we use this, you can say, relation, which is evolving from the property of similarity of triangle. So first of all, this relation is very useful. Alright, this is point number 1. Now point number 2, length of direct common tangent AB. AB is the length of direct common tangent. If you draw a parallel line like this, parallel to MN, it will look like this. Can I say AB? If this point is, let's say, Q, can I say this triangle ABQ is right angle triangle? And you want to calculate the length of AB. So where this part is concerned, this is R2 minus R1. And MN is the distance between the center of two circles. If this is D, then this is also D because this line and this line are parallel. So triangle ABQ is a right angle triangle. Can I say AB is basically D square minus R2 minus R1 square under root, can I say? So length of direct common tangent is the distance between center MN D square minus difference of radius square. So we can easily calculate the length of direct common tangent. So this is your note number 1. This is your note number 2. Now note 3 is the length of transverse tangent. Is the length of transverse tangent. So simply, if I draw the parallel line, right, like this, if I draw the parallel line like this, if you extend this part, right, AM and let's say this point BQ is parallel. So can I say this is R2 and this would be R1, R1. So again, if this is 90 degree, can I say this is again 90 degree? Alright. So length of the transverse tangent, can I say BA is QM? BA is equal to QM is the transverse tangent. And this is nothing but MN square minus R2 plus R1 square. So MN square minus R2 plus R1 whole square. So the length of transverse tangent, we can memorize this formula, D square minus sum of the radius whole square. This is your note 3. So let us have a quick recap. Note 1 is PA upon PB is equal to PM upon PN is equal to MA upon NB, and MA and NB are radius to R1 upon R2. Note 2 is the length of direct common tangent. So D square minus difference of radius whole square. What is D? D the distance between the center of two circles. What is note 3? D square minus sum of the radius whole square. So D is the distance between the center, and R2 and R1 are the radius of two circles. I hope this is fine. Alright. Two circles of radius 5 cm and 7 cm have center that are 9 cm apart. Find the length of the common chord. Find the length of the common chord. So one of the circle having radius 5 and second circle having radius how much? 7. So this is your one of the circle and these are 9 centimeter apart. So some part is overlap. This is 9 centimeter. Length of the common chord. We want to calculate this length. This is your radius. This is again radius. This is again radius of the circle. This is again radius of the circle. So this length is 7, 7, 5 and 5. And this is your direct common tangent. Can I say if this is x, this is also x. And this length is basically 9. So length of this part is 9. Now just focus upon this triangle. Let's say AB is the common chord and C and D are the center and this point is E. Area of triangle ACD is how much? We can use Heron formula because 7 is known, 5 is known and this 9 is known. So it is S is 759 by 2 S minus A, right now 21 by 2 is one of the side. S is 7 plus 5 plus 9 by 2 is 21 by 2, right? So A plus B plus C, you know, A plus B minus C, 7 plus 5, 12 minus 9 is 3. And 7 plus 9, 16 minus 5 is 11. And 9 plus 5 minus 7 is 7. And this is 2, 2 and 2. Just using Heron formula. Can I say 7, 3, 21? This is 21 root 11 upon 4. Is the area of triangle ACD. And we can also write the area of triangle ACD as half into base into height. So base is CD, half into CD into X. X is the height. This is 90 degree. This is again 21 root 11 upon 4. So it is half CD. CD is 9, you know. X 21 root 11 upon 4. 2, 2. So basically X is equal to 21 root 11 upon 18. And 2x is the length of the common chord. AB is x plus x to x. It is 2 times 21 root 11 upon 18 is basically 21 root 11 upon 9 centimeter is your answer. I hope this is fine. Alright. I'm sure first point is clear. We can calculate the area of the triangle from Heron formula. And we can also express the area in terms of half into base into height. This must be equal. So we can calculate x. Once x is known, we can calculate the 2x. So this is your answer. Such type of questions in the common chord can also be asked. Now come to the application of the theory we discussed little while ago. MR is a transverse tangent. MR is your transverse tangent, right? This is M, this is R. Center of circle is P and Q. The radius is 15 and 9. Find the length of BC and find the length of MN. First of all, what is the length of MN? MN is the direct common tangent. MN is the direct common tangent. So what is the formula for the direct common tangent? First of all, calculate the second part. The length of direct common tangent. You know the formula D square minus R2 minus R1 whole square. D is the distance between the center of two circles. So what is the distance between the center of two circles? Is 40 centimeter given in your question. So it is straightway 40 square minus R2 minus R1. So radius is 15 and 9. So 15 minus 9 whole square. So basically this is 40 square is 1600 and 15 minus 9 is 6 square is 36. This is 1564. Okay, so 1564. Alright. D square minus R2 minus R1 whole square. Distance is 40 and R2 and R1 is 15 and 9. Alright, is the length of direct common tangent. Now, so far the first part is concerned, the length of MR. MR is the transverse tangent. In fact, third part, MR is the transverse tangent. And what is the length of MR? MR is D square minus R2 plus R1 whole square is the formula. So D square is 40 square and R2 plus R1 is 15 plus 9 whole square. So 40 square is 1600 minus 24 square is 576 is basically 1024 is 32 centimeter. Right. Now come to the first part, BC. What is the length of BC? If you want to calculate the length of BC, then we can use this property. PM is perpendicular and this is again perpendicular. Can I say triangle BMP? Triangle BMP is similar to triangle BRQ. Can I say? BMP, this is 90 degree, this is again 90 degree. So BMP is BRQ, and this is point A, this is point B, and this is point C. Now if I use the similarity of triangle, BP upon BQ is basically MP, right now, MP, or you can say PM upon QR, which is radius of the circle is 15 upon 9 is 5 upon 3. Okay, if this is 15, this is also 15. If this is 9, this is also 9. Can I say? This is 9, then this is also 9. Now, what is BP? BP can be written as BA plus AP, and this is divided by BC plus CQ, and this equal to 5 upon 3. BA and BC and AP and CQ. Can I say AP and CQ is in the ratio 5:3? So something upon something plus something upon something is 5:3. So AP and CQ are basically the radius is already in the ratio 5:3. So this and this should be also in the ratio 5:3, because 5:3 plus something is 5:3, then something must be in the ratio 5:3. So the ratio of BA and BC is again 5:3 for sure, because this is 5:3, this is 5:3, so this is also 5:3. So what is the length of this part from here to here? The length is 16, is 40 minus 24 is equal to 16. Can I say AC is equal to 40 minus 24, 15 plus 9 is 24, total is 40, 40 minus 24 is 16. If you divide 16 in the ratio of 5:3, then it would be 10 centimeter and it would be 6 centimeter, and you want to calculate the length of BC, so your answer is 6 centimeter. Can I say this question require all the property that we had discussed little while ago? Alright? Okay. Now come to the next question, question number 63. The radius of the circle having center P and Q is 16 and 9, and there is a small circle inscribed between these two circles and their direct common tangent. So find the radius of this circle. We want to calculate the radius of this circle. Find the radius of this circle. Now, for the time being, let's assume that radius of this circle is A. Radius of this circle, this small circle, is B, and radius of this circle is C, where A and C is given. And let's say this is point A, point of contact is point B, and this is point C. Right? And let's say this is point O. So PO means if two circles touches each other, then the line joining the center passes through the point of contact. If two circles touches each other, then the line joining the center passes through the point of contact. Now tell me one thing, just forget this circle having center at Q, just focus upon P and O. Can we calculate the length of AB? AB is the length of direct common tangent. Can I say this length is nothing but the length of direct common tangent? And you know the formula, the length of direct common tangent is d square minus r2 minus r1 whole square. What is d? So far, circle with center P and O is concerned, d is the sum of the radius. The distance between the center is sum of the radius. So it is a plus b whole square minus r2 minus r1 whole square. Can I say this is a minus b whole square? A is the radius of the circle, b is the radius of the circle. So a plus b whole square minus a minus b whole square is 4 times ab, is basically 2 times under root ab. So we can calculate ab. In the similar fashion, can we calculate bc? Similarly, can I say BC? In the same fashion, we can calculate the length of BC. This time we have circle having center at Q and O, and we have radius B and C. So this is similarly 2 under root BC. In the similar fashion, we can calculate AC, this whole length AC. AC is how much? Again, we can use the same formula. D square minus R2 minus R1 whole square, length of the direct common tangent. Can I say this AC is the direct common tangent? If I ignore the smaller circle, then D is what? The distance between the center of two circles, P to Q. Can I say this is A, this is C, so A plus C. So A plus C whole square minus A minus C whole square is basically 2 times under root AC. Now, according to your question, AB plus BC is equal to AC. So, if I write 2 under root AB, 2 under root BC is equal to 2 under root AC. 2 cancel. So, under root A, B, under root BC is equal to under root AC. If I simplify this one, if we divide this equation from under root ABC, if this is divided by under root ABC, it will look like 1 by under root C plus 1 by under root A is equal to 1 by under root B. You can treat this one as your direct formula to deal with all such kind of question. So 1 by under root C, 1 by under root A is equal to 1 by under root B. the radius of inscribed circle can be straightway calculated by this formula, 1 by under root 16 plus 1 by under root 9 is equal to 1 by under root b. So this is 1 by 4 plus 1 by 3 is 1 by under root b. Alright, so we have 1 by under root b is equal to 7 by 12. So root b is 12 by 7. So b is 144 upon 49 centimeter is my answer. So whenever two circle and there is inscribed circle, then the radius of inscribed circle between the circle and their direct common tangent is always satisfy the formula 1 by under root a plus 1 by under root c is equal to 1 by under root b. I hope this is fine. Alright. So we shall start the next part from the rest of the part of circle, and we shall also cover the rectangle, square and other quadrilaterals in the next class. Thank you.